A 3.2 kilogram steel ball strikes a wall with a speed of 9 meters per second and an angle of 60. It bounces off the wall with the same speed and angle. If the ball is in contact with the wall for 0.2 seconds, what is the average force exerted by the wall on the ball? So, this is our little diagram, and to find the force exerted, we have by the wall, we have to break it into the horizontal and vertical components. So, that's like the two parts of this question. So, we have our horizontal force. Here are our horizontal momentum bar graphs. Notice that momentum is not conserved because there's a force acting on the ball. And that's like what we're looking for. And it'll make more sense when I get into the math. But since there is a net force that's not zero, momentum is not conserved. So here's our little equation. Delta P, we're not going to use this. We can just use, it's M delta V, which is just, delta V is just final minus initial. Since, okay, we're talking triangles, since, this is the angle, this is the opposite of the angle, it's the sine. And this is negative, the final velocity is negative because it's traveling in the negative x direction. And the initial is positive because it's traveling in the positive x direction. This negative is just that. So you get negative 2 v sine of 60 times the mass, which is, you just plug in, you substitute, and you get negative 66.5 newtons. For the vertical force, momentum is conserved vertically, which really threw me off. That was the part that I really struggled with. I tried to calculate a number for this, but it's not. This is the more conceptual part of the problem. So I know that it's conserved because it's going positive and then, or it's going negative and positive. So we're using the same equation. Delta P is M delta V. Again, delta V is just final minus initial. For this one, unlike the x, the final is traveling in the positive direction, and so is the initial. They're both going upwards, but they're being subtracted, so that's why it cancels out and turns into 0 newtons. That was the part that really messed me up. I tried to find out a number for the vertical component of it, but there isn't. It's just 0. So, yeah, that's how I solved this problem.